Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing great. Let's go ahead and get this thing started with a word of prayer. Dear Heavenly Father, I want to thank you for today, Lord. I want to thank you for all you've done. Please help us have a good afternoon. Help my students learn. We love you, Jesus. In Jesus' name we pray. Amen. All right, guys. So today we're going to be covering lesson 7.3, and we're going to be learning how to use similar right triangles. This is page 449 if you're following along in a book. When the altitude is drawn to the hypotenuse of a right triangle, the two smaller triangles are similar to the original triangle and to each other. That's theorem 7.5. If an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So, as you can see, these three triangles are all going to be similar, okay? So, identify the similar triangles in the diagram. So what I like to do is I like to start at the right angles. Okay, so there's a right angle, there's a right angle, and here's a right angle. So let's start with the big one, and then I go up the short leg and down the hypotenuse. Okay, so triangle EDF is similar to triangle GEF, which is similar to GDE, okay? And that's all there is to that. That's pretty basic, pretty simple. So let's go on to the next slide, because as we go along, the examples are of course gonna get a little bit harder. So here we go. The figure shows the side view of a tool shed. What is the maximum height H of the shed? So you know that this little section here is 9 feet because it's right here, and with all the information we just learned, we can figure out the height of this triangle by comparing these similar triangles. So the first thing I like to do is, obviously we need this bigger triangle because it has all three sides. And then, honestly, you could choose this triangle or this triangle to solve for the height. So, here we go. Let's go ahead and we're going to use this triangle. So, I'm going to draw the two triangles. First, I'm going to draw the bigger one, which has the hypotenuse is this line right here, which is 17. Okay, the short leg is 8, and then, sorry, that's really hard to see. And then lastly, the long leg is 15. Then I'll draw the other triangle. You know what? I changed my mind. I'm gonna use just this little triangle right here, whose hypotenuse is 8. Okay. And we're wanting to know its long leg right here. Okay, so X, okay? And that's all we need to know, because as long as you know three sides, so 2 on one triangle and then 1 on the other, you're able to solve using a proportion. So let's compare our hypotenuses. That's gonna be 8 over 17. And then set that equal to X over 15. The two long legs, X over 15, okay? We cross multiply. 8 times 15 is going to give us 120, which equals 17x. Divide each side by 17, and you're going to get roughly 7.1 feet. So X is roughly 7.1 feet. So you know that the distance of this line is 7.1. So you have 9 feet and 7.1 feet. So all we have to do to find the total height of the shed is add those two things together. So 9 plus 7.1 equals 16.1 feet. Okay, about 16.1 feet is going to be the total height of the shed. All right, guys, I hope that made sense. Let's keep on rolling. So, geometric means. In lesson 6.1, you learned that the geometric mean of two numbers a and b is the positive number x, such that a over x equals x over b. Consider right triangle ABC form theorem 7.5. You know that the altitude CD forms two smaller triangles so that these three triangles are similar. Notice that CD is the longer leg of triangle CBD. Okay, CD. And the shorter leg of ACD. The shorter leg. When you write a proportion, compare the leg lengths of CBD and ACD, you can see that CD is the geometric mean of BD and AD. As you see below, okay, CB and AC are also geometric means of segment lengths in the diagram. So anyways, real quick review, geometric mean, where A over X equals X over B. If you have the same variables here, that's the same thing as, X equals the square root of A times B. Whew. Okay, so here's where it's about to get a little complicated, but hold on, we'll ride through this together. Okay, proportions involving geometric means in a right triangle. So here you have a bunch of proportions, and remember, they're basing this off of if your triangle is labeled in this fashion, A, C, B, D. And I would recommend, even if it's lettered different, I cross them out and solve for all the sides using this because it's easier to compare to this chart. Okay, so here's some of the geometric means. The length of the short leg 1 over the length of the short leg 2 equals length of longer leg 1 over length of longer leg 2. Length of the hypotenuse 3 over length of hypotenuse 1 equals length of short leg of 3 over length of short leg of 1. Length of hypotenuse 3 over length of hypotenuse 2 equals length of the longer leg 3 over length of the longer leg 2. Anyways, so many letters. Try not to get bogged down, and whenever you're solving any of these, try to remember that you know other ways to solve sides. So you can always hop back to the Pythagorean theorem and so on. Anyways, for this one, what we're going to do is let's go ahead and draw the two triangles we're comparing. We're comparing the bigger triangle with this little triangle. So like I said, I like to draw the triangles. This is 10 and K are the only parts of the big triangle that we know. And then the littler triangle, we know the short leg 2 and the hypotenuse K. So if we set up our proportions, this is really nice. Hypotenuse 10 over K equals short leg K over short leg 2. Okay, now all we have to do is solve this. As you see, it's a geometric mean, so we could just jump to K equals square root 20, which 20 breaks down to 5 and 4, where 4 is a perfect square. So K equals 2 square roots of 5. Okay, hope that made sense. Let's keep going. Last theorems we're going to learn, and we're going to use both of these in our next slide, is theorem 7.6, the geometric mean altitude theorem. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the length of the two segments. Okay? So, then theorem 7.7, geometric mean or leg theorem. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of a right triangle is the geometric mean of the lengths of the hypotenuse of the segments of the hypotenuse that is adjacent to the legs. Whew! lots of words. We'll put it into practice on the next slide. But the first thing I want to remind you, I like to relabel whatever triangle I'm working with to match these to see if I could set up any of these proportions with the numbers I know. So you are standing by a tree as shown in the diagram. A 25-foot ladder is leaning against the tree. The ladder is 5 feet away from the base of the tree. That is the length of a piece of rope that goes. What is the length of the piece of rope that goes from the base of the tree and is perpendicular to the ladder? So they tell us that this is 5 feet from the tree. The ladder is 25 feet, and they want to know what the length of the piece of rope is that would connect these perpendicularly. So the first thing I want to do is let's go ahead and draw ourselves a triangle. And this would be A, B, and C, where this is also D. Okay, we know that the full length of A to B is 25 feet. So 25 feet, okay? We also know that this is 5. And from that, we're able to solve all the things we need to know. So first, if we look at theorem 7.1, I'm going to pull that up and look at it again. 7.7, the geometric mean or leg theorem, okay? We have AB and CB, which means that we could solve for DB, this short little section here, okay? Using this part. So let me pull this up here. AB over CB equals CB over DB. Okay. We can use this proportion because we have enough of the parts. You have to have either AB and DB and solve for CB, or you need to have AB and the CBs, okay? And you'll be able to solve for DB, which is our case. Okay, so AB is 25. 25 over CB, which is 5, equals CB 5 over X. We don't know what DB is, but that's what we're solving for. Well, this comes out to be 25 equals 25x when we cross multiply. So X equals 1. Okay, so we have 1 right here. DB equals 1. And with that, okay, now here we have some options, okay, guys? We could use the Pythagorean theorem to solve for CD, which is totally acceptable, where you do 1 squared plus x squared equals 5 squared. And ultimately, that's what you're going to get if you do it the way I'm going to do it. But I'm going to pop back to theorem 7.6, the geometric mean altitude theorem, which says that, here, let me draw some lines around this. It says that BD over CD equals CD over AD, okay? And we have all that information that we could plug in. So BD is 1 over CD, which is what we're trying to solve. We'll call that X, equals CD, which is X, over AD, which is 25 minus this 1, so this is 24, okay? I should have labeled that, I'm sorry. Now all we have to do is the geometric mean. So X is going to equal square root of 1 times 24, okay? So X is going to equal roughly 4.9. That's a 9, okay? So CD is about 4.9 feet. Okay, that's all there is to it. I know that seemed complicated, but like I said, don't get bogged too down in this, because we could have simply, instead of doing this, with this information we had here, we could have just used the Pythagorean theorem, which is totally fine. At least I think it is, because that's the beauty of math. There's more than one way to do anything. So anyways, you guys, I hope this made sense. Please like, subscribe, comment, whatever you want to my video, as long as it stays positive. But anyways, guys, have a good day. See ya!